Well, there you have it, Bharat Surya Astra. It is essentially the power of the sun that we hope to harness here. On Times Now, we have been getting you the live relay, which is coming in a telecast from ISRO itself, as Aditya L-1 mission is on its way to a very successful launch. 7 made in India payloads, of course, are on it. India's first solar probe aims to study the solar winds, which can cause disturbances on the Earth, which are, of course, commonly called auroras, and that is what it is going to be studying once it is there, once it gets into orbit, which is the Lagrange point 1. We are going to go across to our own set of panelists who are going to explain to us what really is expected in the next few days. In fact, there is Girish Lingana, an aerospace analyst who's joining us, Shantanu, an astronomer and space communicator. Also, Abhijit Chavda is joining us, an astrophysicist. Now, interesting bit for us to understand what happens from here onwards. Girish Lingana, I'm going to come to you for that. What happens from here onwards? We know that it's taken off. It is in an area which it cannot be monitored right now. However, it takes over 140 days to actually reach that landing spot. What happens in the interim? You're muted, sir. If you can just unmute yourself, Mr. Lingana.
It is similar. Can you hear me now?
Yes, we can hear you now. Go ahead.
Yeah, it happens similar like a Earth raising orbiting maneuvers. Like it goes, you saw in Chandrayaan-3,
Yes.
it went 3, did the perigee firing. So when they come to a correct angle, then that perigee angle they call it as, after that it will be injected to the trajectory path. And from there it goes to the L1 point, which may take roughly approximately 120 days or something like that. Okay, so it's same Earth maneuvers, and then only we can go through this trajectory part to reach the L.
So then it's headed towards that area where it hopes to park itself. And Shantanu, you must explain to us, why are there these 5 specific parking spots? How does it help the entire mission to ensure that Aditya L-1 reaches one of these parking spots? What are the benefits of being there?
So these 5 spots, as they have been called the L spots, so these are points around the Earth or any two-body system, like in this case, the Earth and the Sun, and along with the Moon, that where the gravity of both the planets, both the objects kind of balance each other. So if we go closer to the Earth is pulling us with its gravity. So we get pulled towards the Earth. If we go closer to the Sun will try to attract us and we'll be pulled closer to the Sun. But at these 5 points, the pull of both the Sun and the Earth balance each other. So in a way, they could be like these points where we could stay forever without moving away from that point. So out of these 5 Lagrange points that we have, the 5 L points, 3 are actually the stable ones. 2 of them are quite a little unstable, but the 3 that we have spoken about, including L1, where Aditya is going, are points where if the spacecraft goes a little, a little outside the region, it will be pushed back. So it's kind of a stable point. And from that distance, we do not have the Moon coming in between the Earth or the satellite and the Sun. So there is no obstruction in the view of the satellite.
So it's an uninterrupted view, Shantanu?
Exactly. It's an uninterrupted, forever there's going to be no obstruction, no eclipses. So we can have a continuous monitoring of the Sun, what's happening on it, around it, and at that point also.
Which is why it's important that it's one of those spots so that it has an uninterrupted. If there is an eclipse, for example, then it still has a very clear view of the Sun. Now, Abhijit Chavda, you must explain to us now, once it does arrive at L1, what exactly does it hope to research and look into? We do know that it is going to be looking at solar wind particles. If you can explain that a bit.
Right, yes. So once it arrives at the L1 Lagrange point, it's going to start, it's going to deploy its instruments and start collecting data. So this essentially is a coronagraphy spacecraft. That's the main mission. A coronagraph is an instrument. It's like a telescopic attachment. If you point it at the Sun, it's going to block out the disk of the Sun, so you can see what's around the Sun, which would typically be, we would not be able to see because the Sun's intensity is so bright. So it's going to essentially study the solar atmosphere, the atmosphere of the Sun. It's going to study the solar magnetic storms, and of course, what kind of effect and impact these storms are going to have on the environment around the Earth. So one of the problems we in India face, as scientists in India face, is that we have to rely on foreign data, on foreign observational evidence and all that. We have nothing of our own. So for the first time, we're going to have our own satellite, our own spacecraft in place with an uninterrupted view of the sun. It's going to be collecting data, sending it to us, and we're going to be analyzing that. So that's mainly what it is. And there are mysteries around the sun. For example, there is this big mystery that the corona of the sun is about, about 1,000,000 degrees Celsius, whereas the surface of the sun is about 6,000 degrees Celsius. And this is something that's been known for about 7 decades, and it's still not understood why this is so. There are theories as to why this happens and all that, but it's still not proven as to which theory is correct and why this is so. So this is a huge mystery that people have been working on for the past 7 decades. It's still not resolved. So this is going to give us and our scientists the first opportunity to take fresh data and try to resolve this mystery. So these are some of the things that we will be doing, and also the effect of the solar wind and solar coronal mass ejections and other things like that on the Earth's atmosphere, how long it takes for that to propagate and reach the Earth, and what is the composition of that from a nuclear physics perspective, from a particle physics perspective, what sort of plasma characteristics it has, and so on and so forth. There's a whole bunch, an array of instruments that's deployed that is part of the package on the spacecraft. So we're gonna be able to do all this for the first time in I don't know how long. We're gonna be doing fresh science, actual science with our own instruments, with our own spacecraft, and we're gonna have the first mover advantage in this case. So it's a great step forward for Indian science.
And there aren't too many developing nations who've managed to get that close to the sun. And I think that's one of the biggest takeaways. Many have said that it is the foresight of the Indian space mission that we have put ourselves in pole position when it comes to ensuring that we are way ahead of the other nations, even some of the developed nations when it comes to space exploration. We are going to be slipping into a short break. We'll return in 2 minutes. Don't go anywhere.